and I'm here as well. Can you hear me? Okay. Oh, get up on stage.
Let's do it. Oh, you've got the clicker, right?
Yeah, I've got the clicker, so just say click and I'll click.
Fantastic. Sounds good.
Welcome, everyone. So, welcome to the Building a FHIR Client session.
Totally. So this, I guess, let's start with a quick word of warning to you guys. This presentation, let's just say it's in beta. Mirjam and I have been individually doing the HAPI Java overview intro course and the .NET overview intro course, respectively, at these events for ages. And we got to talking at the last DevDays about what we could do to change it up a little bit. And we realized there's really not much point in splitting them. So we thought, let's try combining the two talks, which is always a challenging. I'm sure we're going to be stepping on each other a little bit, figuring out how to do this. But I also think it'll be interesting, just because there's a lot of parallels and a lot of sort of interesting, subtle differences between the two. So hopefully this will be good. We would love, I think I speak for both of us, we would really welcome feedback on the format after this, just because this is, as I say, the first time we've tried doing this way. Hopefully it'll work well. Maybe it'll be super boring. We'll see.
I think it won't be super boring. So this slide tells you a little bit about us. I'm from the FHIR team, but you could see that from my yellow shirt as well. So, well, let's just start. This is the first session we do today. After this, we will have a session that does the hands-on coding. So after this, we will invite you to come with us to the meeting rooms, which are next to the jack, and try out building your first FHIR client, either in Java or .NET, doesn't matter. So, I think this is better, or not? I don't know if it's on.
Oh yeah, it's on. I think I'm louder, but there we go.
Yeah, okay. Well, I can talk loud as well. So, of course, you need to know a little bit about FHIR, but if you were new to FHIR, you probably went to Rick's introduction to FHIR just before our talk. And that should get you started on this topic. And then either know something about Java or C#, be comfortable with your development environment, and then, well, we'll start with coding. So first, a quick recap on FHIR. We have FHIR offering you a model and in the form of resources and data types. So this example shows you a bit of the patient resource. That's the model. Then FHIR also describes a RESTful API for interacting with systems. And well, you see a RESTful search here as an example on my screen. So you can code something that implements this search or the other API interactions, reaches out to the server, and then get back a response from that. And that's all described in the FHIR specification. So
cool. So a little bit about versions, of course. FHIR, as I'm sure you guys are well aware by now, has had 3 releases: DSTU 1, 2, R3, and hopefully R4 will be coming by Christmas, Graham said. We will see about that. The libraries we're talking about here do support all of those versions, so there is absolutely support for any of those FHIR versions. I think all of our code samples we're going to show you today are around the current version of FHIR, that's DSTU 3, but really for anything we're going to talk about today, nothing significant changes between those. I always like to give a disclaimer that we'll sort of interchangeably say DSTU2, R2, STU2. I don't mean anything by different, there's nothing different about any of that nomenclature. Ultimately, it's just that we used to say DSTU, and then we dropped the D, and it became STU, and then we decided it would be R4, and I don't know, it confuses my brain. So don't infer anything by the different vocabulary there.
So a little bit about the background of the APIs. Well, you're the Java guy, so you can talk about this slide about Java.
Let's do it. So, HAPI began life way back in 2001. The HAPI project started. It was started as an open implementation of the HL7 version 2 standard. It was at the time sponsored by a company called University Health Network up in Toronto, Canada, where I'm from. We had this use case way back then where we wanted to exchange HL7 v2 messages with a hospital across the street from our own, and thought, oh, there's no open source libraries out there that we could use for that. Got to work building an API and eventually decided, hey, this is useful enough, let's open source all of our work. That was the beginning of the HAPI project. Fast forward way up to 2012, and we got super excited by this new standard called FHIR and thought, hey, let's build a HAPI module for that. So that's the beginning of the FHIR project. Those two projects are completely, I mean, they're related but totally separate. They have their own GitHubs and stuff like that. And there's not really, other than the fact they're open source HL7 implementations, there's not too much that sort of goes between the two of them. What else is worth mentioning? We are licensed under the very, very business-friendly Apache 2 license. We are strong supporters of people using the code in any way they want, and that certainly includes commercial products. So if anyone is building, you know, something which you intend to sell, absolutely feel free to throw HAPI in there. We are very sort of supportive of that. We're also, of course, very welcoming of outside contributors, outside sort of contribution in whatever form it takes. So, I mean, as open source projects go, we try very much to adhere to the ethos of that.
Okay, thank you. So much of that holds for the C# library as well, in the sense that it's open source and we welcome anyone wanting to contribute. The .NET library for FHIR exists since 2011 because, well, that was the first DST1 release or start of FHIR, and Ewout has been developing it since then. Of course, we have had contributors helping us out to get the library up to standard as it is now. So you can find the source on Ewout's GitHub, and there's some documentation on the link that you see on the screen as well. And I think it's worth mentioning that James learns from the .NET API, and the .NET guys learn from the Java API as well. So whenever James invents something really cool, we try to implement that in the .NET library as well, and the other way around. So you will find lots of similarities between them, even though, of course, there are differences in syntax and sometimes new things added that were not copied over to the other library. But that's why we could do this together, I think. So there's some code examples, and there's the link on this slide as well. So if you want to take a look at that during the hands-on, you're free to do that and ask us any questions you have after that as well. Then, let's start with the libraries. So first, the FHIR model. You can see the using statement used in .NET, but you can also see the packages that you can use for the Java library on this slide. So again, my next slide is Java first. That's not intentional, but sometimes I switch it the other way around. But it's your turn again, James.
Sounds good. So of course, I mean, in the Java ecosystem, of course, libraries are distributed in jar files. All of our jars are available through the standard Maven repositories, which means if you're using Maven as a build system, or Gradle, or Ivy, or any of those things, you should be able to just edit the configuration file for whatever your build system is, bring in the dependencies you need. Most importantly for HAPI, you're going to bring in one of what we call our structures jars. The structures jars have a version of FHIR in them, so you'll take the DSTU2 structure jar, or 3, or the R4 one, or even multiple. So you can certainly, within a single application, bring in several versions of FHIR and use all of them within an application if you want.
Yeah. So for .NET, that's a little bit harder. We have different NuGet packages for all of the versions, mainly for DSTU2, 3, and R4 as well. They all have this HL7.FHIR.model namespace, so if you want to work with two of the libraries together, then you'll have to do some work around that to get this working. But it is possible. So, yeah. Well, you can mix as well, but it takes a little. I think it's not as intuitive as in Java, that one. So the FHIR resource, this is an observation resource. You can find these structures on the website, or if you use a profile, you can see those things on a profile registry like Simplifier. So get familiar, if you're not yet, get familiar with this tree structure to see how a FHIR resource is structured. So this is an observation, and you can see all the fields that are inside of the observation. And if we are going to take a look at our libraries, you'll see that in C# there's a partial class called observation. It's a partial, so you can extend it if you need it. Then within this class, of course, you will find all of the fields that you see in the tree structure. You will find the several things in there as well. So for example, the status will be inside of the class definition as a property. So in this case, the status field is a coded field, and if you look at the definition of the status field, you can see that this code is a required code. Let's see if I can, well, I don't know where the pointer is, but you can see that says required. That means that you have to take one of the codes from the code set that's listed there, and for each of those required parts, we have created an enumeration, so you're able to use that enumeration to fill in the code for that specific field. And here you'll see an example of doing that, where we fill in the observation.status with the observation status preliminary. Yeah, well, that's a difficult word to pronounce. But, well, as you can see, you can make use of those predefined enumerations for the required sets. So you'll always be assured that you have the correct codes in there.
Cool. So buried within those structures jars, and I think this is probably going to be the same across both libraries, we have a set of classes that define, of course, all of the FHIR resources. There's a super interface that you will see sort of at the top of our hierarchy that covers every single version of FHIR, every resource. That is the iBase resource interface. This you will see littered throughout the entire API. All of our server framework, all of our client framework, all of the tools that we'll talk in sort of later sessions today, all of that sort of, they all hinge around this iBase resource interface that is at the top of that hierarchy. Moving down the hierarchy, there are separate versions of each of the classes for each of the resources. So we do have a version of the DSTU2 patient resource. In a different package, we've got a version of the DSTU3 patient resource. And then in another package, we've got the R4 resource. And that's how all of those work. Let's move to the next one. Which is? Yeah,
so again, here you see the example in Java, which I set with the enumerations. And you can see that Java does the same as the .NET library in that respect. So the next one is the data types. And actually, this is a combined slide with both Java and C#, because, again, you can see the similarities. All of the primitive types, they are... well, they have classes assigned to them, and for primitive types in Java, you can see that it's called the name and then type attached to the name of that primitive type. So, for example, a string type or a Boolean type. Well, in .NET, it's almost the same. It's just that we call them FHIR and on the type name. So, for example, for the string, we have FHIR string and we have FHIR Boolean. So, just a matter of different syntax, but the ID is exactly the same. For the more complex data types in FHIR, we have data type classes created, of course. So you'll see the address or the human name data type, etc. So the complete model, as you can see on the FHIR website, is represented in the classes both in Java and in the .NET library. Anything you want to add to that?
I think that's it.
Yeah, so here we have a data type example where we have a code within the observation resource that's of type codable concept. And as you can see, the codable concept is a class on its own. So we have this codable concept part, and you can get them or set them. And in Java, you have a setter and a getter as well, but it's not on my slide. For the 0 to star or 1 to star, if you find them, lists in the specification, we have the list mechanism. So both in Java and .NET, again, we have a list of that specific data type defined on those fields. And of course, you can use the normal list operations that you know to work with those lists and arrays. So, don't know if you want to comment on this one. But
sure. What else is worth saying there? I mean, there's not much more to add here, other than I guess it's worth pointing that we've tried really hard to use this sort of API design known as the Fluent Model for building APIs. You'll sort of see in all of our example code, we use these long chains of methods. Everything in HAPI is designed so that you can kind of conveniently do it that way. The one criticism people love giving Java, and I think it's totally fair, and certainly people coming from .NET say it all the more, it's a very verbose language. There is a lot of boilerplate. We've tried to do what we can to sort of avoid that within HAPI, and one little thing we've done there is this sort of chain everything together. So, you know, while you're building identifiers, while you're building codable concepts, anything like that, everything is sort of designed so that you can at least sort of group things together in a logical way.
yeah, so that's a subtle difference. You can't do that all the time in .NET. Sometimes we will have some Fluent notation as well, but not on all the parts of our model. Okay, so I've mentioned primitive types, like string, like Boolean. No, nothing new there, right? So if you look at this one, this is the patient resource in a different view than the tree structure. But you can see that you have this active field, which is a field of type Boolean. So you would say, okay, easy enough. I can develop this. I can put a true or a false in it if I am going to fill this patient .active field, right? You're right, but primitives are not really primitive. So if you are going to look at the model, you'll see that for this active field, you can find two things in our .NET and also in our Java code. Let's see, yeah. So you can see we have an active element and we have a normal active. So the normal field is just what you would expect. You can fill in the Boolean value in this normal field. But you will also see this active element field, and basically it points to the same thing in memory, but it's the non-primitive version of that field. And you can fill it in like this. So, for example, I create a new patient, and I have this either active element put in a new FHIR Boolean, or a Boolean type in the case of Java, and I can fill that with a true value. Or I could use the native type, just the primitive type, and fill the patient.active with the value true. So there's two ways to do this. Don't get confused. You'll see them both, but you only need to use one, and that depends on what you want to do. So why would you use the non-primitive version? I have an example here where I have created a new human name. So this is a C# example again. So I've created a new human name object, and within the human name you have the family field. This family field is primitive of type string. So this is my last name. It consists of two names actually. One is my partner's name and the other is my own name, my maiden name. So at the moment, if I want to say something about that extra, then I can use extensions. Do you all know about extensions in FHIR? Who doesn't know about extensions in FHIR? Okay, well, they are extra bits of data that you can put on certain fields. there's a nice extension mechanism for that. And actually, most people will run into having to use extensions. So the moment I would want to indicate that one of these two parts of the name is my partner's name, I can use an extension for that. It has been defined already somewhere, so I can use an extension on that. But if I would try this on a string, well, a string is a string, right? Nothing else. You can't add anything to it other than just fill it in with the string value. So you can't add extensions, if you need them, on a primitive value. And that's where you use the FHIR type. So in this case, I can use the family element, and then I can add an extension to that. So nice bit of code. Is there anything you want to add on this node?
No. You know what? I mean, I guess this is the one spot where there's an advantage to us both talking. Just in case the last few slides have confused you, I'm going to say them in a slightly different way, just because I feel like this is, I always hate explaining the whole notion here and whatever. Let's try it. I mean, there is a simple concept in FHIR, of course, called extensions. Anything almost in FHIR can have extensions. You can put extensions on resources. You can put extensions on infrastructure elements within resources. You can put extensions right on primitive data types. And each of those has their own purpose in life. Oftentimes, you don't need to interact with you don't sort of have extensions on primitive elements. So the patient.active example, of course, is a great one. Generally speaking, you're going to say patient.setActive, and you're going to pass in a simple Boolean true or false into that. If you have the use case where you need to put an extension right on one of those primitive values, that's the only time you need to interact with that sort of that thing we call element. So that's the only time you're going to need to say patient.get active element. That returns this thing called a Boolean type in Java, or just a what do they call it in .NET? Just a Boolean, I guess a capital B Boolean or something, right?
No, it's the FHIR Boolean.
FHIR Boolean, that's it, thank you. All those things is a simple wrapper around a primitive Boolean, except that they've also got a placeholder for extensions to go in them, and that is the purpose of that type. So, I mean, don't get overly confused by this. The whole idea is that you've got a place for extensions if you need it. Truthfully, extensions on primitives, you don't need to do that very often, so mostly you'll just be interacting right with the underlying primitives.
In the Netherlands, we do use the example of the family name because it's important for us to somehow put those things in a certain order and things like that.
The Dutch like to be different. We get it.
That's why I have this family thing up on the previous slide. So yeah, we use that a lot. So if you're Dutch and you're going to implement the Dutch patient profile, then you will probably see those extensions in your data. Yeah. Okay, thank you. I think the batteries are dying on the clicker. Yeah, so there's another thing called choice properties, where you can see this X notation if you look at the definition. So in this case, we have some field called value, and it can take several types of values. So for those, we call those choice properties because you have to choose which kind of data type to fill this field in with. So as you can see, if I look at the definition within the libraries, you can see that we make use of the element type, which is the base type for all the data types. And for you, it's type, right, in Java. So yep. For .NET, it's called element, and for Java, it's called type. So that's basically it. All of the data types derive from that base type. So you'll have to declare the type, or you have to create some thing of the type, and then fill this field in with that specific FHIR type that you've chosen. Yeah, then there's something called, well, what we call components. Within the FHIR structure, you can see these subfolders, and in this case, I've just snipped a little bit out of the observation resource, where you can see that observation has a reference range component, as we usually call it when we're talking about that. So that's a block of information having, again, subfields inside of that. For each of those constructions on components, you can see that they derive from backbone element. As a normal user that sees the FHIR data, you will never see this backbone element, but in coding, you will encounter that type. So you can see, for example, that we have created a class, in this case for the reference range, we add component to it, so you can see that we are talking about this extra group, a block of data within a resource type, and it derives from the backbone element type. And well, actually that's the same in Java, right, James?
Yep.
Oh. Cool. So, so that's the model. It will take you a little bit to get used to working with the model. So that's why we invite you after this session to come with us and try things out. So we can show you the intricacies of all of the things that you can do with that. Next up, we have serialization and parsing. If you're going to do that in C#, you use the HL7.FHIR.serialization. And I've also put in the context on this slide because that's important for Java.
Yep.
And that's what James will talk about now.
Cool. So, a couple of key concepts as far as parsing goes, and really, I guess these are probably the two biggest gotchas when you get started with HAPI/FHIR. The first is absolutely everything revolves around this thing we call the FHIR context object. The FHIR context is a class you will use first off to ask for parser serializers, but also to ask for clients, to build servers, to do validation. Really anything you'd want to do, you're going to start with a FHIR context object. The biggest gotcha that there is in dealing with HAPI/FHIR is this. Do not create parser, or let's try that again. Do not create FHIR context objects over and over again. They're fairly heavyweight to create, but they're intended to sort of live for the lifetime of your application. They're totally thread safe. They don't leak memory. They don't have any problems like that. So there's nothing wrong with creating one and keeping it in static variable for the lifetime of your application. You can use them in multi-threaded contexts, any of that type of thing. Just don't sort of go about creating a new FHIR context every time you're creating it. You're doing a parse or creating a client or anything like that. The context object can be asked for what we call a parser in HAPI/FHIR. This is sort of the other confusing point. We've got this thing called a parser in HAPI. The parser handles both parsing as well as serializations. There's not a separate encoder or a separate serializer or anything like that. You'll do both of those operations with this thing you call parser. And that you can get just by creating a context object and then asking it for a parser.
Yeah, so the example of that is on this slide, where you can see what James explained, parsing and then serializing as well on the bottom there, right, by encoding to string. Yeah.
And I guess, I mean, we should mention here, I don't know if the class name is up there. No, it's totally not. Doesn't matter. On the GitHub, which we showed at the start, and I'm sure we'll show again at the end, and I'm sure we will dig into during the next session, all of the code samples we're showing here are in that GitHub. So if you want to sort of get started playing with parsers, if you want to, a starter project, if you want to see any of this code, it's all up in that GitHub repository. And that includes actually these two languages, but there's also some iOS Swift stuff in there. There's a bunch of HTML. So really, I mean, pick your poison. There's lots of good tutorial material in there.
Okay, so I also have an example of parsing and serializing in C#. As I said, you are using the HL7.FHIR.serialization, but in that you will have a parser and a serializer class. So you can create a parser and parse some stuff. Of course, well, it's not important what it says within this JSON text reader. That's just, well, you can access your file system, you can put in a string, whatever you have available, and then parse that into a memory object. And then, of course, serialization is, well, the same way with the serializer, and then serialize to string or to a document or things like that. So there are several methods inside of the serializer in C# as well. So try them out. Yes, so once you're comfortable working with the model, you're able to create your resources and you're able to read them in and do stuff. but what kind of stuff would you want to do? You want to communicate those resources. So we also have created the method to create a FHIR client. So there's already, well, the HTTP things, you don't have to worry about that. The libraries will handle that for you. So for C#, you are going to use hl7.fhir.rest, and for Java, you will use the generic client. And we've got 2 examples on that. Well, perhaps you want to do the REST recap.
Sure. So, I mean, one of the biggest parts of the FHIR spec actually is this entire RESTful specification. You're not required to use REST while using HAPI or while using FHIR, and there's plenty of sort of use cases that involve doing FHIR but not using the REST API. But truthfully, I would say most people who do FHIR are doing the RESTful world. The REST sort of API is incredibly rich, and we absolutely don't have time here to talk about all of its intricacies and all of the features in there. There's basic stuff like CRUD, and I've got a bunch of examples up here of how we do, simple creates and updates and reads and logical deletes and that. There's an entire world of searching and conditional updates and transactions. There is really a ton of power in there, and certainly, I mean, all I'm going to say here is if you haven't sort of started digging into all of the power of the REST API, do yourself a favor and go and look at all of the documentation that's in there. Really, the main point here is that all of that power has been encapsulated both in the Java client and the .NET client. So, I mean, truthfully, one of the nicest ways of learning the API is actually just to start typing some code and hit control space or command space or whatever it is in your IDE and see what the methods are that are available in the 2 clients.
Yeah. Okay. So, using a FHIR client, 2 examples here. In C#, you just create a new FHIR client object and point that to the FHIR server that you want to reach out to. It doesn't do anything yet, of course. It will just create this in memory. And only when you are going to perform one of the operations, then it will reach out and perform the correct HTTP call to that server. And in the Java case, of course, you need to have this context we talked about earlier, and then you can set your client to your server URL as well on the context.
I will say very quickly, there are 2 types of clients. I'm not going to dwell on the annotation client at all. It's a really cool feature, but probably not something we have time for right now. The generic client is the sort of nice Fluent build up a call by chaining methods together. All of our examples use that. And truthfully, whatever you're doing, probably the generic client is the one you want.
Yeah, and there's some documentation links as well. But please come and code with us later on, so you can just try it out instead of reading the boring stuff. You can talk to James and ask him questions. That's better, I think. So yeah, we have this create example in Java. I didn't put in the update and delete things, but that's something that you can just try out. So here's some code, and as James said, on our GitHub you can find the rest of the code as well. So you can just copy paste and try it out. Well, I always am, and what I have seen in Java, and I'm not a Java developer, is that you don't forget the execute. If you forget the execute method, then nothing will happen. So I don't know. That's perhaps my ignorance of the Java language, but I have encountered other developers that were trying this out and forgot to put in the execute to really reach out to the server. So it's.
Right. Just to drive that one home, because it's true, this is a common source of bugs with the HAPI client. Every method chain always ends with .execute, and that's the thing which actually makes it happen. So a create, for instance, is going to be client.create.resource, and you pass in your resource .execute, and that last step is vital, because nothing happens otherwise.
In C#, it does happen as soon as you do the create method. So you've got this client.create here on the bottom of my screen, where we send out a patient to be created. So no execute method there. It will just be executed. So searching, another important part is, of the FHIR specification. There's a powerful searching mechanism in the FHIR specification, which you can read on the website, of course. But of course, we are interested in coding the searches. So for example, we have a patient called test, and we want to have a birth date before 2014. And this is the normal call you would do if you're on an HTTP client. If you try it with curl or Postman or Fiddler or something like that, you fill this in. So this is an example call. And this is what it looks like when we are going to do the search in Java. So anything you want to add here about what's said? So that's almost, I think, the search on the previous screen, where you fill in the certain values that you need and then execute the search. When you do a search, you will always get a bundle returned. So that will be a bundle FHIR resource. And then you'll have this bundle.entry list of the entries that result from your search. So that's why in the end you will take a look at, if you want to do something with what's inside of there, you see this get entry part. You look at the entries inside of the bundle and then well, do whatever you need with the search results. And this is the one for the Java, where I also have just set a couple of the questions we put in our search and then execute this search. And as you can see here, we can do a Fluent notation, but we can also just add anything to this search params object that we are creating to be able to add extra key and value pairs for our search. So you can do it multiple ways, or whichever flavor you like best. Do you want to talk about the interceptors?
Yeah, I mean, we don't necessarily have time to really go into these. I will say very quickly, there is an Interceptor Framework on the client. It allows you to layer functionality on top. There are a ton of built-in interceptors. There's also the ability for you to write your own. They can be used for things like logging, like adding security headers, like adding other headers, changing responses, changing requests as they go out. Honestly, a lot of the questions we get on our Google group, the answer to whatever is asked about clients, usually it's write an interceptor to do that thing. So be aware that there's a lot of power in the Interceptor Framework, some built in, some that you can code yourself.
Yeah, so this example is about the auth interceptor, where you can fill in the authorization headers and things like that. If you want to do that in C#, you'll have to make use of the events that are available to you. So I have this example where we use the onBeforeRequest event, adding extra headers to each request you send out. So if you have a token and you want to send that with a .NET FHIR client, then this is the way to do that with the onBeforeRequest event. And then after the response, you have the onAfterResponse event that will fire when you get back the response, and you can handle the raw response that's in there. If you need to do other stuff, then just look at the normal result that's in memory. We're almost through, so we're
awesome.
Doing okay.
We are doing okay.
So, well, yeah, so I said almost through, but are there any questions at this moment for either James or me or both?
And I think, I guess before we get to that, one other thing I will add. In terms of, I mean, if you're looking for help on either of these APIs, I mean, certainly there is Zulip. There is the FHIR chat group. If you guys haven't seen chat.phir.org yet, it is amazing. It is like 24/7. There are people asking questions and answering questions and stuff like that. Really, really good resource. The reason I mention it is just to say the HAPI library itself does have what they call them streams on Zulip. I would say, as far as HAPI questions go, truthfully, there's an even better resource there, and that's our HAPI FHIR Google group. I mean, if you want to find that, truthfully, just go on Google and type HAPI FHIR Google group, and you will find it as the first hit to that. We've got a really good community there. Lots of people asking questions, lots of people answering questions, that type of thing. And of course, because it's a group, you can search the history really easily. So there's a whole lot of richness in there. I don't know, what's the best way to look for help on the .NET side?
I think, well, we do have a group as well on Google, but it's not that active. I've seen the Java group, that's really more active. Reach out to me is a good one as well. Just use my email address, mirjam@phir.ly, and then I'll direct you to anyone. If you have any issue with the library, because it's a GitHub repository, you can shoot in any issues there. But usually if it's just a question, please just reach out to us to ask the questions instead of making an issue there. Yeah, so we've got 1 minute left. Then we are going to move over to the meeting rooms. But is there anyone that has a question for this last minute here? Yes, in the end.
So first of all, great talk, very clear, thank you. And I'm interested in file profile. So for things like, if I want to restrict the cardinality, I want to change the range or define my own extension, how do I express that in your libraries and how is it going to get executed?
Yeah, so the question is about profiling. If I have constrained cardinality and things like that, how do I express that in the library? Do you want to comment on that, James?
Sure. So I mean, I guess I don't know if you're interested in Java or .NET, but it doesn't really matter. Let's talk about both of them, and probably most of the answer is the same on both. I mean, first off, you know, depending on what you're doing, you don't necessarily need to even sort of worry about the sort of extending the data model. The base, you know, the patient Java class or the patient C# class can be used to express really anything, any sort of profile on FHIR, as long as that profile is valid FHIR. You can add extensions to patient resources, to data types in those resources, any of that. If something is constrained out, you can just plain not use that field. Like if you've constrained out patient.active, you can just not sort of populate that bit of data. So to build profiled types, you don't necessarily need to build custom models, and honestly, most people don't. That said, you can absolutely extend the model in both Java and .NET. You are certainly welcome to extend, like to create your own sort of my patient class that extends the built-in patient class. On that, you can add things like extensions. We do have, certainly in Java, there's a mechanism for you to create your own fields in those classes. You give them special annotations that say this is an extension, this is its URL, this is its data type, so on and so forth. There's a bunch of examples of that up on our website that show how to do it. The one thing that we don't currently have a good way to do is to constrain stuff out. There isn't really an easy way currently of building a patient class that does not include the active flag. You could do it, but it's really a big pain in the butt, truthfully.
Yeah. And my last remark, because we have to stop, is both libraries have validation mechanisms inside. So if you have the structure definition of your profile, you can validate your patient object against that specific profile. So before you send it out or when you receive data, just validate against your profile and you'll know if it's good or not. Thank you for your attention. I hope to see lots of you in the meeting rooms, because that's where we will go. Well, feel free to come up to us and ask anything you want about the libraries later on. Thank you.
Thank you.